So now we want to look at adding and subtracting rational expressions. And again, this is going to just follow from the same rules we would use with adding and subtracting fractions. But as we know, that can be a little bit more complicated than adding or multiplying or dividing fractions, right? Because we have to have the same denominator. So if we do have the same denominator, like if we're doing 5/3 plus 8/3, then we simply just have to multiply the top numbers. Okay. So the reason that we're able to do this is because 5/3 plus 8/3, if we think about what we're saying, right, this is like saying that we have 5 1/3, right, and that we have 8 1/3, and we want to think about how many do we have total. Well, if we factor the 1/3 out, we have 1/3 times 5 plus 8, right? So we have 13 1/3, which is 13 thirds. Okay. When we're first doing fractions, we're often tempted to do something like 5 plus 8 over 3 plus 3. But of course, this is not true. 13/6 and 13 thirds are not the same thing. One of my favorite examples of this not being true is 1/2 plus 1/2. If this were true, is 2 over 4 equals 1/2. So 1/2 plus 1/2 equals 1/2, which of course doesn't make any logical sense. 1/2, half and a half have to equal a whole, right? So same idea with the rational expressions, right? We don't want to just add the tops or the bottoms or anything like that. We're going to need to find a common denominator and then add the tops, right? Or subtract in the case of subtraction. So if we just have something simple like 5 over x, so this example, 5 over x plus 6 over y, okay, we have to get a common denominator. So the least common multiple of x and y, we don't know what x and y are. They don't have any kind of known factors. So their least common multiple is just going to be the product of the two. So it's going to be x times y. So we're going to multiply this one by y over y and this one by x over x so that we can find a common denominator, right? And remember, we're allowed to multiply whatever we want as long as we multiply both the bottom and the top by that same number, because this is just equal to 1, right? X divided by x is equal to 1, and anything times 1 doesn't change. So we're not actually changing the numbers here. So this is going to be 5y over xy plus 6x over xy. And now they have a common denominator, so we can add them together. 5y plus 6x over xy. Okay. Sorry, I don't know why this is making extra markings. All right, so now let's do another example. This one happens to have subtraction, but yeah, it really doesn't make too much of a difference. So 6 over x squared plus 4x plus 4 minus 2 over x squared minus 4. So we're looking for the common denominator of x squared minus 4 and x squared plus 4x plus 4. So it's a good idea if we're looking for the least common multiple of these two to kind of factor it first so that we can see what kind of factors they share. Okay, so this is 6 over x plus 2 minus 2 over x plus 2 x minus 2. Okay. So this tells us that their least common multiple is going to be x plus 2 times x plus 2 times x minus 2. In other words, if we multiply the left term by x minus 2 and multiply the right term by x plus 2, then we'll have the desired denominator. Okay, so let me squeeze it in over here then. I'll write in a different color here. So we're going to multiply by x minus 2 over x minus 2 And we're going to multiply this one. I guess I can put it right here by x plus 2 over x plus 2. Okay, so I'm just squeezing it, but we're just multiplying the top and the bottom, the numerator and denominator, by the same things. So this is going to be 6 times x minus 2 over x minus 2, x plus 2, x plus 2, minus 2 times x plus 2 over the same thing, x minus 2, x plus 2, x plus 2. Okay, now it's better probably not to multiply the bottom together yet, because there might be a common factor at the end. We need to multiply the tops together though, so that we can combine these. So this is going to be 6x minus 12. There's not a lot to do here, so I'll just go ahead and erase and rewrite. And this is going to be 2x plus 4. Okay. So now we'll go ahead and subtract these. So 6x minus 2x equals 4x. Negative 12 minus 4 is negative 16. X minus 2, x plus 2, x plus 2. Okay. Now we can take a 4 out of the top. So we're going to get 4 times just x minus 4. So it looks like there's nothing that's going to cancel here. So with that in mind, we could just leave it like the left-hand side, or maybe we just want to write it out, multiply everything out. So we'll just go ahead and write out 4x minus 16. This is going to be x squared minus 4 times x plus 2, because those first two are the difference of two squares. And then we'll have 4x minus 16. So let me scroll over x cubed plus 2x squared minus 4x minus 8. Okay. But honestly, I think it's fine. You can just leave it in the factored version. It doesn't need to be multiplied out unless it explicitly says to. Usually the simplified version is the factored version. So if it says simplify, you can leave it as a factored version of it, which would be like this one right here. Or maybe you take the 4 out. It doesn't matter. There's a lot of different ways to write this, and I'm personally not picky about it. So let's go ahead and do another one here. Okay, so we have 3 over x plus 5 minus 1 over x minus 3. Okay, so here we, they don't have any common factors, so their least common multiple is just going to be the product again. So we multiply by x plus 5 over x minus 3 on this side, right? So that we get x plus 5x minus 3, and then we'll multiply this one by x plus 5 over x plus 5. So we get 3 times x minus 3 over x minus 3, x plus 5, minus x plus 5 times 1 times x minus 3 over x plus 5. Okay, so we'll get 3x minus 9 minus x plus 5 over x minus 3, x plus 5. Okay, so now we'll do the subtraction on the top here, and we'll get 2x, right? Because we get 3x minus x. And the negative 9 minus 5 will be minus 14. Okay. So x minus 3x plus 5. So we can pull a 2 out of that to see if there's a common factor, but in this case, there will not be. Okay, so let's do one kind of more complicated example where we have, these are sometimes referred to as complex rational expressions. Okay, so this is where we have rational expressions inside rational expressions. Okay, so let's just do it as an example. So we have 2c over c plus 2 plus c minus 1 over c plus 1 divided by 2c plus 1 over c plus 1. Okay. So there's a lot going on here, but there's nothing new going on here. We're just kind of putting it all together now. So we have division and we have addition. Okay. So order of operations would say that we should simplify the top and the bottom of the fractions first. So like this part and this part, and then do the division. Okay. So the bottom here can't be simplified, but we can simplify the top by finding a common denominator. Okay, so the common denominator will be c plus 1 times c plus 2. So we're going to have 2c over c plus 2 times c plus 1 over c plus 1 plus c minus 1 over c plus 1 times c plus 2 over c plus 2. And then the bottom's just going to come along, right? Nothing to do with that yet. So if we just do that multiplication, we'll get 2. Let's think, do we want to multiply out yet? Yeah, we do want to multiply the top out so that we can combine them, right? So we'll get 2c squared plus 2c. And I'll just go ahead and put it all over 1 right away. Okay, so they're over c plus 2 times c plus 1. So from the first one, we have 2c squared times 2c. From the second one, we have c squared plus 2c minus c. So plus c minus 2. Okay, and then again, we don't want to leave that denominator behind. So we'll bring that along. Okay. So now on the top, we have some common terms. We get 3c squared plus 3c minus 2 over c plus 2, c plus 1 over this whole thing. So now we want to think, can the top be factored? So let's see, 3 and 1. It doesn't look like that can be factored. So let's just, so let's go to the next step here. So now we have, obviously it looks pretty messy at this point, but ultimately we just have a fraction on the top divided by another fraction on the bottom here. So this will be equal to 3c squared plus 3c minus 2 over c plus 2, c plus 1, and then times the reciprocal of the bottom. So c plus 1 over 2c plus 1. Okay. So the c plus 1s will cancel, and that's it. So now we have 3c squared plus 3c minus 2 over c plus 2 times 2c plus 1. And that's as simple as we can make it. If there was a factor, if we could factor the top, maybe there would be another common factor, but ultimately our goal was to go from this expression, which has fractions within fractions, and turn it into just one singular fraction.